Okay, Assalamualaikum and good evening, everyone. So we are going to present about the lab 3, which is constructing the programmable logic controller, which is open-ended experiment. So I'm going to introduce our group mates. First one is Muhammad AQIL bin Nasaruddin, 202592. Myself, Muhammad AIMAN bin Muslim, 203694. KAMAL SHOAIB bin 204455, YEONG 200561, and Muhammad YEONG AQIL bin AZARY 20459. Next. So this is a table of content for our presentation. The first one is introduction, theory, apparatus and methodology, result and discussion, and the last one is conclusion. So we have wasted any time. I pass introduction to Kamal.
Thank you, Ayman. Now I would like to continue my first, which is introduction. PLC is an industrial computer which has numerous uses such as automating electrochemical activities that includes equipment control on factory assembly lines, amusement rides, or light fixtures. PLC is also known for their extraordinary flexibility and accuracy. Before the invention of PLC, the control function were handled by hardware control method handled by contractors. The components required to finish an operation would be wired by electricians. In case there is a mistake, the wire need to be rejoined. That's all from my part. Now I'd like to pass to my next group.
Okay, for the theory, present. Thank you, SHOAIB. For the theory, programmable logic control, which is PLC, is in non-priority term, and the objective was to directly replace the electromechanical relay as logic elements, replacing them with a solid-state digital computer with a store software capable of simulating the interconnection of numerous relays to accomplish particular logical operations. And next theory is logic control system were planned and built exclusively around the electromechanical relays before the arrival of solid-state logic circuit. Before then, relays are far from obsolete in a modern design, although they have been superseded in many of their past duties as logic-level control device, with a high current and or high voltage switching being the most common application. Okay, next. This is the apparatus for the experiment of the PLC, which is we got a computer and a PLC 8 or AV with a wire, and next is the push button, and next is electropneumatic system element. Next. And for the methodology, we're going to start first by the PC turned on, and then the PLC was turned on, and the software before step 7, microwin SP5 started, and then the view selected, then ladder selected, and then the bit logic double given by the lab assistant was formed. Then normally open contact was clicked. Then the red question mark will click on, and the normally open contactor was renamed with the physical input name I0 till I07 or I1 till I1.5. From the bit logic, the output have been double clicked, and the physical output name was named, which is Q0.0 till Q0.7 or Q1.0 till Q1.1. And next is PLC that comply all selected. The total error has been confirmed not happen, and then the PLC then stop was selected to place the PLC in the stop mode. Next, to download the ladder diagram to the PLC, download was selected, and the window for downloading appeared. Download was clicked, and then the PLC was placed in the run mode by selecting the PLC run. The PLC is ready for use performing the function of the ladder diagram that has been drawn. Next, I will pass to other teammates to present.
So thank you, Wise. So I will continue for result. For first, this is the picture shown in the slide. This is the first arrangement for our circuit. So when the switch was pressed, the LED light was turned on, and then when the switch was released, the LED was lit. So next. So this is the second arrangement. In second arrangement, the LED light was turned on after 10 seconds. When the switch was pressed because of the timer, the X1 switch was pressed again, and the LED light was turned off. So next. Can you play the video? So as you can see, when we turn on the switch, we need to wait 10 seconds before the LED light turn on. So next slide. So this is the third arrangement. We replace the timer with a special internal relay, which will make the LED light blink continually after the switch was pressed, and then it was turned off after the X1 switch was pressed again. So next, can you play the video? So as you can see in the video, the LED light blink continually because of the special internal relay. So that's it for my part. I will pass it to next presenter.
So as for the discussion part, so for experiment one, when the X0 normally open switch button was pressed, the circuit was closed, and then the current flow through to energize the R1 coil. And then the latching occurred as the parallel R1 contact energized the Y2 output. So as the result, the LED was turned on. However, when the NO switch button was released, the LED was not turned off because even though the NO contact was de-energized, but the latching is still occurring. So the circuit was remain to be energized. So for experiment 2, normally closed contact and a delay timer were used. So when the normally open button was pressed, the circuit was closed and the R1 coil was energized. So parallel R1 contact was energized and the latching of circuit occurred. So the delay timer was energized and the LED lit up after 10 seconds as the delay time was set at 10 seconds in the software. So the normally closed switch was pressed to open the circuit and the latching was stopped, and then the LED was turned off. So for experiment 3, the delay timer was replaced by the special internal relay of R901C. So when the normally open switch was pressed, the circuit was closed and the latching occurs. And then the R901C relay was energized and the Y1 output was energized. So as the consequence, the LED blinked every 0.1 second due to the R901C relay, which has the 1 second clock pulse relay. So I'll pass it to the conclusion.
Okay, thank you, YEONG. Okay, next. So as a conclusion, we can conclude that our experiment is done successful as it meet our objective. First, we are able to understand the fundamental of ladder logic programming and how to connect the wires according to the ladder diagram. And we are also able to analyze each of the component functions used in the PLC circuit. able to conduct 3 different experiments, including the using of switch, buzzer, and LED in the PLC circuit. And so in this experiment, we are only using the LED light. And as a result, 3 different experiments was running, and the 3 experiment, which is the program was successful construct, and the components were able to perform its responses respectively. So next. So that's all from us, group 2B. Thank you very much.